Okay, so this is for geometry, lesson 1.5, and what I've done is kind of taken the like all of the big things that you need to know from this lesson on Apex, and I've copied and pasted them in here. So that's why it looks similar to what you see on Apex. Okay, so kind of think of this as a study guide, and then I will show you. We'll do like some little notes off to the side here, okay? Okay, so the first thing that it starts talking about is like in the Apex lesson, it talks about like using postulates and theorems and proofs in geometry. But before we can use any of those things, like to show logically that one thing maybe leads to another thing, we have to know the basic definitions of geometry, okay? So this first definition, it says, the most basic object in geometry used to mark and represent a location, it's called a point, okay? Points have no length, width, or height. That's kind of a big deal. I think this is one of the possible quiz questions. So points have no length or width or height. So essentially a point is just like it's literally a point in space. So like we just have a point and we label it with a letter, typically a capital letter, okay? If you look at your example here, it says lines M and N intersect at point P. So there's kind of an example. They show you this is like line M, this is line N, and they intersect at this point, which they're calling P. So a point is typically like an intersection of two lines or segments or rays or something like that, okay? And so all the rest of those words we're going to learn in a second. Okay, so then a line segment, it says, is part of a line with endpoints at both ends. So we kind of think of a line, which doesn't come until later, but essentially a line is just like it's straight and it goes on and on forever in both directions, okay? That's a line. So a line segment, it says it's part of a line with endpoints at both ends, okay? So it's straight like a line, but it has an end point here and an end point here. So maybe we call this, like this is A and this is B. So we call this a segment, line segment AB. And this is the notation that we use to show like what a line segment is, okay? You know what, I'm gonna write that. I'm gonna write that down a little bit further. So this is line segment. It just has like a bar above the two endpoints. So you have the two letters that are at the end of the segment, and then you have a bar above it. And that's how we show what a line segment is, okay? And that's it. Okay, so then this next one talks about an endpoint, which we just discussed. So like in that last, in this last example that I just showed you, the last definition, this point A is an endpoint. This point B is an endpoint. It's just like a point at the end of a ray, end of a line segment, or the end of an arc. So we'll talk about a ray and a line segment today, okay? So the endpoint is just like, it's just the actual points on the end. So A, B, there's an endpoint C there. Okay, so that's an endpoint. Okay, the midpoint, it says it's the point halfway between the endpoints of a line segment. So let's say we have a line segment again, and I'm just going to name it the same thing. So we have a line segment AB, and then right in the middle of that segment, so I'm just going to kind of guess for this one, we have what's called the midpoint. So right there, I'm going to label that with another point, another letter, C, and then that point right in the middle is called the midpoint. Now, what happens with a midpoint is, I'm going to change the color real quick. It splits the big segment in half. So originally we started with a segment AB. That means now the length of AC, so the length of half of that, and the length of CB, the other half, are exactly the same. So like if this segment is 8, then this segment is 8, okay? Or maybe if we knew the whole segment was 16, then we know that each half, since C is right in the middle, each half would be 8 because you just divide 16 by 2, or you split it in half, okay? So that's a midpoint. Okay, and then the last one before a little summary here. Oh no, actually there's two more. So a ray, a part of a line that starts at an endpoint and extends forever in one direction. So it says it starts at an endpoint and then it goes on forever in one direction. So it kind of looks like this. It has an arrow on one end and an endpoint on the other end. So I'll say this is A, and then it has to go through another point. You can't just name a ray with one letter. It has to have at least 2 letters. So we're going to say, since it starts with the end point right there is A, it starts with A, it goes through the point B, and then we just kind of draw this like one-way arrow on the top of it, okay? I'm going to do another one. So let's say it's kind of the opposite here. Let's say we have this ray. So this is C, this is D. If I'm going to label that ray, or I guess like have the notation for that ray, it starts with C because C is the endpoint. It goes through D, and then there's a ray. It goes that way. So you always point the ray to the right in your notation, okay? So you start with the endpoint C, it goes through D, and then we're going to the right, okay? Even though the ray kind of goes to the left. All right, the last definition here before this summary, it says a line is the set of all points in a plane that are equidistant from 2 points. So we're just going to draw what we think of as a line. And then in geometry, a line is a straight figure, or like a straight, we just think of like a straight line, and it has arrows on both ends. So it extends forever to the left and forever to the right. Or if you're going up and down, it extends forever down and forever up, okay? Now, it says it's the set of all points in a plane that are equidistant from 2 points. So what we typically do is we just put 2 points on our line, and we're going to name it with 2 points. So this time I'll say line XY. Maybe this one is line RS, something like that, okay? And then the way that we name a line or show the notation for naming a line, if we have that first one is XY, you still just do your 2 letters. It doesn't matter the order. The order only matters in this case for a ray, and you have to start with the endpoint. So we have XY or 2 letters, and then on top we do like an actual line with 2 arrows on both sides. So for the other one, line RS, I have line RS. On top I have the 2 arrows, okay? Okay, so then this is a summary, and actually would be a really good thing, I think, maybe take a screenshot of or a picture of it. It kind of goes through all the definitions that we just went through. So a point, a segment, a ray, a line, and a midpoint. We added an endpoint also, but that was kind of, we didn't really need that definition. And then the last one is, this last thing in red is called the segment addition postulate, okay? So it says the segment addition postulate, if point C is between points A and B, point C is between points A and B if AC plus CB is equal to AB. So what this is saying is that if we have, I'm going to do a different color here, if we have a segment AB, so my endpoints are AB, and then point C is somewhere between A and B, it doesn't have to be right in the middle, but just somewhere in between, then it's saying, and I'm going to use a highlighter here, it's saying if I add this segment, AC, so look at this part right here. If I add that first segment, AC, plus this segment, CB, then I end up with the entire segment from A all the way to B, okay? So if I add the 2 little parts of my segment with a point in the somewhere like in between A and B, then I get the whole segment, okay? So for instance, and you could possibly have this like on a quiz or a test at the end of the unit. Let's say I have this. So we'll say X, this is Y, and this is Z. And so this is pretty basic. Let's say this is 7 and this is 10. And then I want you to find the length of XZ, okay? So we know that since this little part is 7 and this little part is 10, then I just add them together. So 7 plus 10 would be a total of 17, okay? And that's the segment addition postulate. Okay, so that's the kind of the first part of lesson 1.5. So then it moves on to talking about angles. So this is kind of a new definition, and this is huge. We use angles like for a huge portion of what we do in geometry. So it says an angle is the object formed by 2 rays that share the same endpoint, okay? So if we think of what a ray is, here's an endpoint and it goes forever in one direction. So we kind of have an arrow. So I'll name this AB. Now it says it's formed by 2 rays that share the same endpoint. I didn't mean to cross that out. 2 rays that share the same endpoint. So if I have another ray that starts at this point A, okay, So if I start at point A and I have another ray that goes in a different direction, maybe we can name that AC, then this right here, we call that an angle. So that whole thing together is an angle. So angles look like this. You can have an acute angle, or you can have an obtuse angle. That's like a big open angle. So again, it's just two rays and they have an endpoint in common, okay? Okay, so then we have some definitions of different types of angles. So I want to go through this. A zero angle is a ray and measures 0 degrees. So we don't really do much with a zero angle, but basically if they ask you like, what do we call an angle that has a measure of 0 degrees? That's just a special angle called the zero angle, okay? The next one, a straight angle. We do use this a lot. A straight angle is a straight line and measures 180 degrees. So basically what this would look like is if you have an endpoint here and it goes forever to the right, straight to the right, and then my other ray goes forever to the left, it just makes a straight line, okay? So this, like if I start at this ray and I go all the way around to this one, that's 180 degrees is what a straight line is, okay? All right, next one, a right angle. You may have heard of a right angle before. A right angle measures 90 degrees, and it typically looks like a perfect corner almost. We typically will show 90 degrees with a little box in the corner. So this is a right angle that measures 90 degrees, okay? Okay, so then we have an acute angle. So an acute angle right here it says it measures less than 90 degrees. So acute, it's just small. It typically looks something like that. So that little, like the little distance between or the measure between the two rays is just smaller than 90 degrees. And then our last one is an obtuse angle. So an obtuse angle right here, it measures more than 90 degrees. So you can kind of see it's bigger than this, but less than 180. So it looks like here's maybe one ray and it just kind of like stretches out. It looks kind of strange. So that is an obtuse angle, okay? All right, and then we have what's called an angle bisector. So an angle bisector is a ray that divides an angle into two angles of equal measure. In the diagram, FH is a bisector of angle EFG. So I just want to show you this. We're just going to draw I'm going to draw my own little angle here. So let's say I have A, B, C. Now, technically to name this angle, A is what we call the vertex of the angle. It's in the middle. It's the end point of the two rays. So that's going to be in the middle of when I name the angle. So it's going to look like this. You can either name this angle BAC, where again, A is in the middle, or angle CAB. So that little symbol out in front there, which I'm going to highlight in green, this little symbol is for angle, okay? And again, it's important that A is in the middle. Now, an angle bisector says, all right, let's split this angle right in half, and that's not very good. I want it to look like it's split in half. That's good enough. Okay, so this angle bisector kind of splits the angle in half. So we'll call this AD, and what happens when we split it in half is that this angle and this angle, since I split the big angle in half, they are now congruent. They're the same size. So let's say if this angle is 30 degrees, then we know this angle is also 30 degrees. And then the whole big angle, if these are both 30, then it's just kind of like segment addition. It's called angle addition. If those are both 30, then the big angle would be 30 plus 30. So 30 plus 30 would be 60 degrees, okay? So the big angle then is 60 degrees. Okay, and that's what this is talking about right here. So this is called the angle addition tool. In Apex, you can actually kind of like manipulate this. So you can change where point A is, you can change where point C is. But the big idea is that whatever your angles are, like this angle right here and this angle right there, those aren't congruent, which just means this segment, that ray in the middle is not a bisector. It's not exactly in the middle. It's just inside the big angle somewhere. So in order to find the big angle from A to V to B, so I'm going to say angle AVB, I just add those two smaller angles in the middle. So I would do 39 plus 23. and then it tells you right here it's going to be 62 degrees. Okay, so if you have both small angles on the inside, then the big angle, you just add them together. Okay, so there's a couple more definitions. So I'm going to go through and highlight again. And I'll just start with orange. So pairs of supplementary angles. Supplementary angles have measures that add up to 180 degrees. So typically with supplementary angles, what we're going to see, and I'm going to abbreviate here. So supplementary angles, what you normally see is that they make a straight line, and they're like together like this. So maybe this angle is 60 and this is 120. So if this is 60 degrees and that's 120 degrees, then the whole thing from 60 to 120, if I add those together, the whole thing is 180 degrees, okay? So they're typically side by side like that, and you can kind of see they make a straight line when I put them together, okay? Those are supplementary angles. Okay, so then we also have a linear pair. That's actually what I just talked about, those two angles that are side by side. So it says a linear pair is a pair of supplementary angles that are also adjacent. Adjacent just means next to or connected. So if I look at those two angles that I just had, like this angle and this angle, they make a straight line when I put them together. So that 60 degrees and 120 degrees, they're together and they make a line, which means they're supplementary and they're adjacent, okay? So that's a linear pair. I believe that is one of those things that might pop up somewhere. So linear pair means they're supplementary and also adjacent, okay? And then we have another definition of complementary angles. So complementary angles, a pair of angles is complementary if the measures of the angles add up to 90 degrees. If two complementary angles are adjacent, they form a right angle. Okay, so typically we do actually see that our complementary angles are adjacent, but not always. So I'm going to abbreviate a little bit. So complementary, let's just make a right angle here. So that's 90 degrees. And then let's say, okay, I'm going to just draw another right inside there somewhere. Let's say maybe this one is 30 degrees and this one is 60 degrees. So they're right next to each other, and if I add them together, they equal 90 degrees, okay? So they would be complementary, and they form a right angle because they're adjacent. All right, last thing, and then it'll summarize. Congruent. So this is a huge definition for like overall in geometry. We're going to talk about this word a lot. So two things are congruent if they are the same size and the same shape. That's the important part. So have the same size and the same shape. If polygons are congruent, their corresponding sides and angles are also congruent. And then we use this symbol. It looks like an equal sign with a little squiggle on top. So that symbol means congruent, okay? Now, what we typically do is let's say we go back to that definition of a midpoint that we used before. So let's say we have this segment AB, and I'm telling you that this point X is right in the middle. So since X is in the middle, what I know, since X is exactly in the middle, is that this segment from A to X and this segment from X to B are exactly the same, okay? So what we do, I'm going to get rid of these little marks. We use these little symbols right here. Those are called hash marks, and they show that two things are congruent or they're the same size. So like I could also say, okay, this AX, the length of AX is 8, and then here the length of XB is also 8. Therefore, they're congruent, which makes X a midpoint, okay? Because the segments are congruent. So if we have two segments that are exactly the same length, then we use little hash marks, maybe 1 or maybe 2. If they have the same number of hash marks, then we know that they're congruent. They're the same size, the same shape, okay? And then it says, that's this first part right here, hash marks. Then it says congruent angles are marked with arcs. So what we do with angles is slightly different. We're going to say maybe this angle and this angle are congruent, and we want to show that they're congruent. So we put the same number of arcs in them. So I'm going to put like a little arc here and a little arc there. That shows that those are congruent. They're the same size. I could do that with these angles. So if I do that with these angles, to show that those angles are congruent, I already used one arc mark here. So to show these ones, I would put just maybe 2 arcs, okay? And then that shows that those 2 angles are the same size. They're congruent. Okay, so these are all the different types of angles. This is a great summary. You'll find these like at the end of the lesson, right before you take the practice quiz, okay? So acute angles, less than 90 degrees. Obtuse angle, more than 90 degrees, but less than 180. A right angle is 90 degrees. Zero angle is 0. A straight angle, just think of a straight line, that's 180 degrees. Adjacent angles are next to each other. Complementary angles add up to 90. Supplementary angles add up to 180. And then a linear pair, they are supplementary and they're next to each other. So they form a straight line right next to each other, okay? And then angle addition postulate, we did that. This is the angle addition postulate that we did right here. So if you have 2 angles that make up a larger angle, you just add them together to get the larger angle. And then we talked about congruent, and I think that's it.